Hello, and it's Mr. Han again. This time talking about today's lesson, which you're going to see some new notation in this, which might be new to you, but it's nothing different than what you understand and have seen so far. So we talked about graphs yesterday and talking about the growth rate is what we call the steepness or the slope. And today, this gonna see a new notation of that, a different way of writing it. So things to know, synonyms, things that are the same. So when you say the word growth rate in math, that's the same as using the word like the slope, which slope is how steep something is, how steep. And then that could also be, and we'll use this word in the future, like the rate of change. How is it changing? How is it changing? Now, there's a new one they're going to introduce to you in this lesson, and that's the following notation. And that is the kind of the four things which it looks like this. And what this is saying, excuse me, is this is saying the change in y over the change in x. The sign, that triangle sign is actually a Greek symbol called delta that they use. So there's actually math derived from Greece, from the Greeks, ancient Greeks. And it's just a shorthand notation of saying any of these same things. The change in y over the change in x, which is how it's changing, which is the slope, talking about how steep it is, which is like the growth rate. It's all the same. It's all about how things are changing, the rates. So if we look at these lines, I have A, B, and C here, and I asked you what's the change in y or change in x of each. Let's see if we can find it. Now remember that, and I'll use red to help us see this, that y is the up and down. So change in y is your like, think about it as like your vertical change, vertical up and down change. And the change in x is your horizontal change, left and right. So if I look at line A, for example, line A, which is this one here, and I pick 2 points on it, say I pick this point and this point, and I want to know how is it changing. Well, notice to get from here to here, we have to go up 2, and by going up, that's your change in y. So the change in y is positive 2 over what's the change in x? Well, then we had to go right 1. So your change in x is right 1. So line A is 2 over 1. Or you can just write 2 over 1. Mm-hmm. And that's how it's changing. Even like x points, it's going up 2, right 1. Line B, say I pick this point and this point for line B, is it's going, and remember, you always read left to right. Always left to right. So it's going up 1. So that means the change in y is plus 1 over, and then to get to that point, it's going up 1. That's going over 1, 2, 3, 4, 5. Right, 5. So your change in x is positive 5. So you could write 1/5. And now things to think about is like these numbers represent how steep it is. And it doesn't really make sense. In the real world, no one says, hey, how steep is that mountain? Yeah, that's 2 over 1. No one really says that. But if you ever been driving and sometimes you see it says the grade and it gives a percent, the grade is 3%. That actually is the way they use steepness in the world, where they figure out the percent of how much is the vertical change happening as they move forward, which is a little bit farther beyond where we're at. For now, if you can just understand this, eventually we get into how they get that grade percent. But this is basically saying the same thing in a simpler format of line A is going up 2 every 1, line B is going up 1 every 5, right? So the change in y over change in x, which also means the slope or its rate of change. And then the last one, line C, notice that line C is going down. So if it's going down, it should be negative because it's going down. Okay. Now, if we pick 2 points, say I pick this point and this point on the line, And I say, what's the slope? Well, to get from here to here, it's going down 1, 2, 3. So its change in y is -3. And it's going right 2. So then its change in x is still +2. So you have -3 over 2, which is good. And there's the negative. It's actually going down. Its steepness is negative. How is it changing? It's going down 3 tiles every 2 figures. So that'd be if a tile pattern is getting smaller the more you draw. Okay? So that's talking about the new notation, change in y over change x. The vertical change over the horizontal change. Now, you're going to have additional problems to ask you this right here. Graph the following that meet this. So if I draw a graph right here, and there are a lot of answers here. So let me premise there are many possible answers. But say for A, I'll start at 1, because that doesn't matter. But say it's change in y is 3, so that means to get my next point, I'm going to be going up 3, 1, 2, 3. Now I'm going to have a change of x2, and then I'm going to go right 2. And there it is. And you only need 2 points to make a line, so once you have those 2 points, so it's going up 3, right 2, there's my change in y, my change in x. And you could even go backwards. I mean, it has to stay on that same line. So then instead of going up 3, you'd go down 3, 1, 2, 3. And then instead of going right, you'd go left, left 2. And notice you're still at the same point. You're on that same line. And you could check up 1, 2, 3 over 2. It should be the same anyway. That's the nice thing about lines. And then for the next one, let's say I start here at -1. Your change in y is -4, meaning you're going to go down. So you're going down 1, 2, 3, 4. And your change in x is +3. So you're going to the right 1, 2, 3. And there's your next point. And with those 2 points, you should make another point the other way. So go up 4, 1, 2, 3, 4, left 3. And then you have a nice line like that for part B. Notice, by the way, I put arrows on my lines because technically these keep going. They don't just stop at those points. So hopefully that makes sense. If you don't get it, make sure you come to office hours or feel free to email and I can get back to you that way. Good luck on these problems.